These are all the properties of logs, 8.5. Okay, you learned how to do the loop around, so I'm just going to check it. This is in log form, and I'm going to put it into exponential form. 8 to the first equals 8. So if these are exactly the same, these two, it automatically equals 1. If you have any base number, and this is a 1, it should always equal 0, and I'm going to do the loop around. 7 to the 0 power should always equal 1. Okay, the next one, it's hard to read, so I'm going to put it over here. If the log of base b of 3 equals the log of b of x, these are both the log of base b, so can't you just say that x equals 3? The next rule says if you have an exponent, you can put it out in front of the log. If the bases are the same, you can say that m is equal to n. The next ones, if you want to split up these logs, and there's a multiplication sign, m times n, if you want to split them up, you can separate them using the log of base b. But if you want to separate them, you use an addition sign, but multiplying. Same thing with this one. If it's division and you want to break it up, the division sign is really a negative sign when you break it up. I know this was fast, but I think it'd be easier if we just do examples. So let's just do some examples. Don't worry about number 8. So let's just start part 1. And they want you to expand this out. Notice you have an x to the second and a y, and they're multiplied together. So in order to separate them, you're going to write 2 logs of base 8s. And since they're multiplied together, there's going to be a plus sign in between there. This one's going to be for the x to the second, and this one's going to be for the y. And then there's that rule, which was this one right here. This one right here. That you can take that power and put it out in front. So that's rule number 4. So all I'm going to do is to take that 2 and make it a big 2 and erase that. Final answer. And I've seen these problems on the ACT where they ask you to expand the log. So let's expand another log. You have to decide how many logs of base 4s you need. Well, I'm dealing with the x's, I'm dealing with y's, and I'm also dealing with z's. So I need the log of base 4 3 times. 1 for the x, 1 for the y, and 1 for the z. The z is raised to the 3rd power, the y is raised to the 2nd power, and the x is raised to the 1/3 power. You know how to take it out of radical and put it into exponential. We learned that in a different section. Now, the 1/3 comes out in front, and I'd erase this. The 2 comes out in front and erase this. And the 3 comes out in front, and I would erase this. And maybe you want to just erase them. Okay, the x and the y are multiplied together, so there's an addition side, and it's divided by z, so it's a minus sign in between. So that's how you expand them, and I think we have a couple more to do. Yep, we have one more to do. There's a 9, there's an A, there's a B, and there's a C. There's a number, there's the letter A, the letter B, and the letter C. So I need the log of base 3, not just once, not just 3 times, but 4 times. First part of the assignment is expanded out. 1 for the 9, and times A squared times B, you put a plus sign, with an A to the second, with a B, and they're all addition because it's all times, but divided by, the C is in the denominator, and it's C raised to the 2/3 power. I'm going to erase the 2/3 and put it out in front. Squeeze that in there, and I'm going to put the 2 out in front of this one, and that's the final answer. So that is expanding them. Now you're going to go the opposite way. it's in expanded form, they want you to write it as a single log. So they want you to write it as a single log of base 6. When you see a minus sign, you know there needs to be a division sign in your problem. You can go backwards and put the 3 here, and you can go backwards and put the 1/2 here. So it's m to the 3rd on the top divided by n to the 1/2 on the bottom. Final answer. So this is it in expanded form, putting it back into a single log form. Is there another one? Yep, let's do another one. As you can see, they're all logs of base 4s. We're going to write our final answer as the log of base 4. There is 2 negative signs in the problem, which means you need a division bar. This 3 goes above the a, and that's why it's a to the 3rd on the top. The b is in the denominator because there's a negative right there, so it's b squared. And the c is also in the denominator because there's a negative inside in front to the 1/3. Final answer. Okay, the last part of the assignment is solving for x finally. It's an equation. So the first thing you're going to do is combine these two together. The log of base 2 equals sum x. There's an addition sign in between these two. We're going to write it as one single log of base 2. And if there's an addition sign, you multiply these two numbers together. Now that I wrote it as one single log, we're back to what we did in a different section. I'm going to put this into exponential form. 2 to the what power equals 32. A lot of you know that x needs to equal 5 because 2 times itself 5 times is equal to 32. Okay, let's keep doing a few more of these. You know you have a log of base 3, so you're going to write 1 log of base 3. And you know you have a negative sign, so you know you need a division sign. You know that there is a square above the 9, so 9 squared is here. And you know that there's an x in the denominator because there's a negative, it equals 3. Which is the same thing as the log of base 3 of 81 divided by x equals 3. And once it's in one log form, I'm going to do the loop around. 3 to the 3rd equals 81 over x. So 27 equals 81 over x. I'm going to multiply both sides by x to get the x out of the denominator. So 27x has to equal 81. Divide by 27 to get x alone. X is going to equal 3. 81 divided by 27 is equal to 3. Couple more and I think we're pretty much done. As you can see, there's a log of base 2 on the left side. I know that it needs to be x to the 4th divided by 5 because of the minus sign. This also equals the log of base 2 of 125. Notice that there's a log of base 2 on each side, so all you have to do is set them equal to each other without the logs. So I just want to go back to the last problem. The last problem, you only have one log. If you only have one log, you do the loop around. When you have a log on either side, like this one, you can cancel them out and just set them equal to each other. So x to the 4th equals 625. X equals 5. 5 times 5 times 5 times 5, 4 times is 625. Okay, the last one. The log of base 2. I know that these two are going to be multiplied together, and I know that it's 5 to the 3rd, which is 125x equals the log of base 2 of 10 squared, which is the same thing as 100. There's a log of base 2 on both sides. I can cross them out. 125x equals 100. So x is equal to 100 divided by 125, which is 25 goes into there 4 times, and 125 5 times. The answer is 4/5. And that's all you are doing for this section.